So integrated, in short, what we know, that is IC. Have you heard the term IC?
Yes, sir.
So IC stands for
Yes, sir.
integrated circuit technology. So what does it mean? Large number of logic gates or a very complex circuitry is integrated within a single chip, that is known as IC. Okay. For example, one IC having 8 pins. Okay. So this is one IC. So large number of logic gates or a very complex circuitry is integrated within a single chip, that is known as integrated circuit. So as an engineering, when working with IC, we must be aware of the following factor, that is integration level number one. The number two is logic family or the logic technology. Then logic level parameters, and the last one is performance parameters. So you have to be aware about four things. One is integration level. Integration level. Number two, that is logic family. Number three, logic level parameters. And number four, that is performance parameter. Okay. Number four is performance parameter. So have you noted, everyone?
Yes, sir.
Yes,
Integration
sir.
level, logic family, logic level parameters, and performance parameter. So now let's see one by one what is integration level. Integration level is, for example, the integration type is SSI. What does it mean? SSI represent fastest for small, this is scale, and I for integration. That means small scale integration. So for small scale integration, there are less than 12 chips. Okay, less than 12 gates per chip. That is small scale integration. If there are less than 12 gates in a single chip, that is under small scale integration. Next one is MSI. Can you guess M for what? If
So maximum skill. Oh,
can you say S for small, M for
medium.
Medium.
medium, or less than 100 gates. Less than 100 gates per chip. Can you guess this one?
Large. Large
Large
scale.
scale integration. Where for large scale integration, the number of gates, that is 1K. 1K means
1000.
1000. Then VLSI. VLSI stands for
Very large.
very large scale integration. The number of gates, that is 10K. That means 10,000. ULSI. VLSI for very large. ULSI
So ultra.
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 ultra
Ultra
large
great.
scale integration, where 100K. Okay, 100K. And another one is, or the last one is giga scale integration. Okay, giga scale integration, where 1M, capital M represent over here. If K is, then M represent
Million.
million. So 1 million gate per chip, that is under giga scale integration. Okay, so these are the integration level. So is it clear? Integration level.
Yes, sir.
Yes, sir.
Okay, now logic family or the digital logic family. The first one is diode logic. You are familiar with 7 logic gates, right? AND or NAND or inverter or NOR, XOR, XNOR, right? Total 7 logic gates are there. So these logic gates can be designed using either diode logic or RTL, that is resistor transistor logic, RTL. The first one is DL for diode logic. This one is RTL, that means resistor transistor logic. Next is DTL. Can you guess? DTL.
Diode transistor.
Yes, it's D for diode for transistor and L for logic. TTL. Both T represent transistor. So TTL, transistor logic. T for transistor, second T for transistor again, and L for logic. Then CMOS. What is MOS? What is
Sir,
MOS?
fair.
What is MOS? Full form of MOS. M for metal, O for oxide, and S for semiconductor. So MOS stands for metal oxide semiconductor. So here CMOS, that represent complementary metal oxide semiconductor. Okay, complementary metal oxide semiconductor, that is CMOS. Got it? Noted, everybody? It's complementary metal oxide semiconductor. Complementary means opposite. Okay, both PMOS and NMOS. PMOS and NMOS are opposite to each other. So to design CMOS, both P and NMOS are required. That's why it's known as complementary metal oxide semiconductor. Noted?
Yes, sir.
Okay. Now another one is logic level parameters. So what are the logic level parameters? For example, VOL. So what does it mean? V for voltage, O for output, and L for
Logic.
logic. Then A is for
Sir, low and high.
low or high. Very good. So VOL, that means voltage, O for output, L for low. That means low level output voltage. VOA is, that is high level output voltage. If I write VIL, what is it?
Input low.
VIL,
Input low, sir.
low
Voltage
level
input.
input voltage. Low level input voltage. Similarly, VIS, it's high level
Voltage.
input voltage. And BIS, it can be max, or similarly VIS, it can be min. That means high level input voltage maximum value and minimum value. For example, the diode transistor logic DTL. For low logic, it ranges from 0 to 0.2. So what does it mean? This one is minimum low logic, and this one is maximum low logic. Got it? Minimum value and maximum value. For example, it's 4 to 5. That means this one is for high logic, this one is for high logic. So low level value, that is 4, and high level value, that is 5. Got it? Minimum value and maximum value.
Sir, এটা শুধু VIH এর ক্ষেত্রে minimum.
Not only for VIS. Not only for VIS. It
Okay,
can
sir.
be for BIL or OL or OS. Similarly for IOL. What does it mean? The previous one, V for voltage, here I for current. Okay,
I for
not only
current.
for voltage, for current as well. Okay, IOL, then IIL, similarly II is, then I. Okay, all these can have the minimum value or the maximum value. Is it okay? So these are known as the logic level parameters. Either logic is low or logic is high. Either voltage logic or current logic. Either for input or for output. Got it?
Yes, sir.
Yes.
Okay. Then the last one was what? Performance parameter, right? So the performance parameters are fan in, then fan out, power dissipation, propagation delay. Noted, everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Speed, power product, and noise margin. Is it done?
Yes, sir.
Six parameters, sir, for
Total
performance.
6 parameters. Parameters. So what does it mean, the performance parameters? Suppose mobile or cell phone, what you call cell phone or laptop. Okay, suppose you are planning to buy a new device, that your cell phone or a laptop. So before going to purchase, what you have to do? You have to select the model, right? You have to select the device model. And how can you select? By comparing some specifications, right? Got it? So
Yes,
what
sir.
are
Yes,
the
sir.
specifications? What about the battery backup life, then the camera, then the display size, then what else? The RAM,
Yes, sir.
okay, or processor. So these are the parameters to choose the best cell phone or the best laptop. Similarly, these are the performance parameter to select the best logic. Okay, that means to compare different logic families, for example RTL or DTL or TTL, you have to compare these parameters. So fan in, what is it? That is number of input. Fan in is number of input. Okay. So suppose one inverters. How many inputs are there?
So one input.
So
Only one input. But if I connect here, all these are connected to this input, then this inverter has the capability to take only one input, but forcefully how many inputs are connected?
Three input.
three.
3 inputs are connected. Then what will happen? It will take longer processing time to process all the inputs, right? Okay. because its normal capability is to take only one input or single input, but forcefully 3 inputs are connected there. That means it will take longer processing time. Here the fan in is what? The fan in is 1. That means its normal capability to take the input. For example, a 2 input AND gate. So what should be the fan in?
So 2.
The fan in should be 2. Okay, normal input. Is it clear, fan in?
Yes.
So in this scenario, it can run perfectly, but it will take longer processing time. That means it's not its normal operation condition. Okay, it's not in normal operating condition. So the normal operating condition is taking only one input. Got it? That is known as the fan in. So what is fan out? What is fan out? Suppose 2 input AND gate. This is the output terminal, and here 3 different gates are connected. So all these are connected to this output terminal. So fan out is basically how many loads are connected to the output terminal. Okay, for example, this is the output. So IO stands for what? IO stands for, anybody?
Current output.
Current output. That means IO stands for output. Okay. And this one II, that means input current of this inverter. This is another input current of this inverter, and this one another input of this inverter. Got it? So all these are known as unique load. Okay, these are known as unique load. So how many unique loads can be connected to the output of a single gate? That is known as fan out. So it depends on the value of IO. Suppose to turn on this one, or the required current for this inverter is 10 milliampere. This one also 10, this one also 10 milliampere. Okay, and here the maximum current is 25 milliampere. Maximum output current is 25 milliampere. Then how many loads can be driven from this gate? So maximum supply current, that is 25 milliampere, that is the output current. So how many unique loads can be connected where their individual requirement is 10 milliampere?
2.
Right? So that is in for fan out. That means it's IO divided by I. So it can be IOS or IIS, or it can be IOL divided by IIL. Got it? Is it clear? The fan out is the number. So what should be the unit of this? What should be the unit of fan out, or N? Ampere, milliampere, or microampere? What the unit of N?
কিছুই হবে না মনে হয় স্যার।
It's unit free because it's ratio between two current. So let's say this is milliampere, this one also milliampere, so both will be cancelled out. Since it's number, so it will be unit free. And IO is for output current for high state or high logic. Similarly, input current for high logic. And this one is output current for low logic and input current for same low logic. Is it clear? Suppose here it's 35 ampere. Then how many loads can be connected? 35 milliampere. That is the maximum supply current. So easily 3 load can be driven on this gate. So this is known as driver gate, who is driving the load circuit. So this is known as driver gate and this is known as load gate. Is it clear? The driver gate and load gate.
Yes sir.
So for ACE or high state, the direction of current that is from driver to load. Okay, this is the direction of current. Driver to load. For low state, that means the output of this AND gate, it can be either high or low, right? Based on the inputs, the output of this AND gate, it can be either high or low. That means when the output is high, that is under high state output condition. So the direction of current will be this one. And what about low state? That means if the output is low for this AND gate, then the direction will be opposite. That means from load to driver. Is it clear now?
Yes, sir.
So this is known as current sinking. If the direction of current is opposite, that from load to driver, that is known as current sinking, and this is current sourcing. Is it okay? Current sourcing and current sinking.
Yes, sir.
So any query from here, fan in or fan out? No. Now what is power dissipation? What do you know? P is equals to V into I, right? P is equals to V into I. So this is the power equation for AC supply, AC power or DC power. P equals to VI. This one is applicable for AC or DC. Anybody?
Sir, DC.
Yes, sir.
Why DC? If this one is applicable for DC, then what about AC? P is equals to, for AC power, what should be the equation? P equals to
VI cos theta.
I know, but I was expecting answer from you guys. This is for AC, or AC power, and this one is for DC. Okay, so it's VI cos theta. So for this case, the digital logic family, the power dissipation, which is equals to PD for power dissipation, that is equals to VCC into ICC. Okay, VCC into ICC. This is the supplied voltage and this is the supplied current, VCC into ICC. Now the modification or PD average, that is equals to VCC into ICC average. Okay, because the value of current depends on the number of load connected, but the voltage is fixed. That's why it's ICC average, PD average equals to. That means the power dissipation average value is VCC into ICC average. So how can you calculate the ICC average? Do you know the formula to calculate any average value? Not for ICC, any average value. Suppose three numbers are there. Suppose three numbers are there, 10, 20 and 30. So how can you calculate the average value?
We will add and then divide it with 3.
Yes, you will add and divide by the total number. So similarly, ICC ACE. So one current is what? ICC ACE. Another one is ICC ACE. Another one is ICC L, right?
Yes.
So two currents are there, ICC ACE plus ICC L, and it's divided by 2. This is the normal average calculation formula, but this one is only applicable when the circuit is operating under 50% duty cycle. So what does it mean? Suppose this is a curve. Okay, so this is one complete cycle, right? High and low. This is one full cycle. So here the duration is same, both are 50%. That means 50% time high and rest 50% time low. This is the ideal scenario, but in practical it may happen, let's say 60% high and rest 40% low. In that case this one is not applicable. So what we can write, the ICC average value, the ICC average, what we can write, let's say capital X into ICC Ace plus capital Y into ICCL. Got it? This is the most generic equation. The capital X into ICCAs plus capital Y into ICCL. So here, what is X? X is equals to the duty cycle or the high time. So for 60% duty cycle, it's 60% or 0.6. Similarly, the Y, if high time is 60%, the remaining 40% should be low time. So that is 0.4. Is it okay?
X is duty
Is it clear?
cycle for high.
X is duty cycle. Duty cycle means high. Duty cycle means high. Okay.
Yes.
Duty cycle represent the high time. Let's say 50% duty cycle. That means X is equals to what? 50% or 0.5, and rest 50%, that is for Y. Is it clear?
Yes, sir.
Any confusion?
No, sir.
No, sir.
Okay. Now you know how to calculate the average power dissipation. Now let me know the power dissipation should be minimum or maximum. What do you prefer? Power dissipation means how much power is consuming by your device. Okay, it can be your cell phone or laptop. So how much power is consuming by your device? So what do you prefer? More power consumption or less power consumption? Less power consumption. That the power dissipation or PD should be minimum. Got it? So what will happen if my device consume very less power? That means I will get longer battery. Got it? If the device consumes very less power or low power, then I can get longer battery life. That means cell phone একদিন চার্জ করে 3 দিন বা 4 দিন easily use করতে পারবো. Got it?
Yes, sir.
Okay. What about propagation? The propagation delay is related to speed. Okay, that means the processing time or the processing delay, that is known as propagation delay. That is TP. TP for propagation time or propagation delay. Okay, one thing that I forgot, what should be the unit for power dissipation? That means PD or PD average. What should be the unit? The unit for power, that is what you know, it's watt. Okay, the unit for power, that is watt. So in this case, PD or PD average, that is milliwatt. So why milliwatt? Because for digital logic, the current is in milliampere and this is volt. Okay, since the current is in milliampere, that's why the ultimate unit is milliwatt. Is it okay?
Yes, sir.
Okay. Now for power, after power dissipation, the next one is propagation delay. For example, one inverter is there. If the input is 0 applied here, the output will be 1. So the ideal scenario is this is input 0. Okay. Let's say the input is 0. So the output initially 1. And it changes the value. That means it's 0. So output 1. Again, if it changes from 0 to 1, the output will be from 1 to 0. Again 0 and 1. So this is the ideal input output curve. This is input curve and this is output curve. Is it okay? The instant change. But in practical case, this is the practical input curve. That means it will take some change its state from 0 to 1 or 1 to 0. Got it? This is input and output curve. So initially it was 0, so output 1. Again it's 1, so output 0. Again it's 0, so output 1. Is it okay? The left one is the ideal curve and right one is practical curve. So what does we take from the 50% time? Okay. 50% of the changing time from 0 to 1 or 1 to 0. And here the same thing. So this one is TP H to L and this one is TP L to H. Got it? TP for propagation delay and H to L, that means high to low. High to low changing time, and TP L to H, that means low to high changing time. So the propagation delay is basically the input to output changing time. Okay, input to output changing time. Is it clear?
Sir, input to output changing time.
Input to output changing time, that is known as the propagation delay. So the equation for TP average, that means average propagation delay, is, since always we take can you say
Yes, sir.
so it's TP H to L plus TP L to H divided by 2. So this equation is fixed because always we consider the 50% of the changing time. So input 50% to output 50%, and that duration is TP H to L. Similarly, input 50% to output 50%, that duration is known as TP H to H. So divide by 2 because we consider the 50% time. Okay, this equation is fixed whatever the duty cycle. The TP average. Now let me know the TP average or TP or propagation delay should be minimum or maximum. Previous one, the the power dissipation was minimum. Okay, and we know the reason why we prefer the minimum value. Now what about the propagation delay?
Sir, it should be maximum because the faster the better.
Faster the better. So if it takes maximum time, so is it faster?
Delay from
স্যার এটাও মিনিমাম হবে
Sir, এটা তাহলে minimum. Yes, sir.
Minimum. So if it's minimum, that means we will get the faster device. Because propagation delay যদি maximum হয়, that means এটার processing time টা অনেক high. Okay. So both should be minimum. Power dissipation and propagation delay both should be minimum. Now what is speed power product? Can you guess from its name? Speed power product. Can you guess the speed power product?
Power of
Speed means what? Speed means what? From the previous study, the last two was what? One is power dissipation, another one is propagation delay. So here, which one is the speed? The power dissipation or propagation delay?
propagation delay.
sir, propagation delay.
Propagation delay is related to speed, right? So speed power product, or simply SPP. Product means what? Dot or the multiplication, that is product, and speed means propagation delay, that is T, and power means, can you guess? Noted everybody? Speed power product. Noted everybody? speed
Yes, sir.
power product. Can you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
So speed power product, that is the multiplication or the product of speed. Another one is power. Power means power dissipation and speed means TP or the propagation delay. Okay, this is the equation for speed power product. Now what was the unit for PD? What was the unit for PD or power dissipation?
Milliwatts.
Sir, milliwatt.
Milliwatt. And what about TP? I didn't mention. What about TP? Since it's delay, that means related to time. Since it's related to time, so what is the unit for T?
Sir,
The
milliseconds.
unit for time,
Sir,
that is seconds. But here the TP, it should be nanosecond. Okay, it should be nanosecond. TP should be nanosecond. So are you familiar with this multiplier M, micro, N, P, F? Are you familiar? M for 10 to the power
-3.
-3. This one,
10 inverse 6.
Minus 3. Hello.
this one nano,
9.
Minus
12, 15.
P for
Pico. Picometer.
pico, that is -12, not meter, it's pico. This is the multiplier. It can be picosecond or it can be picowatt. And F for femto. Okay, milli, micro, nano, pico, femto. -3, 6, 9, 12 and 15. Now let me know what should be the unit for SPP. Unit for SPP. At first let me know the multiplier. This is nano -9 and this is milli -3. So nano and milli combining pico. Okay, then this is the multiplier. Don't get confused. Here nanosecond. This nano is multiplier and this is the unit second. Milliwatt. The milli is multiplier and this is the unit. Unit of power is watt. Unit of time, that is second. And these are the multiplier. So here pico is the multiplier. Now what should be the unit? Watt second or second watt? Which one?
Pico watt second.
Pico watt second or pico second watt? Now let me know. P is equals to what?
VI.
P is equals to VI. The unit of V, that is here V for voltage, I for current. So unit of V, that is can you see the whiteboard? Can you see the whiteboard?
Yes, sir.
Yes, sir.
So unit of V. Unit of V, here V for voltage. So what is the unit of voltage? Volt, right?
Yes, sir.
And unit of I,
Ampere.
ampere. So in short, what we write, it's V and it's A. So what is the unit of P? Power. Unit of power, that is VA.
Sir, what?
Sir, what?
Similarly, both are not correct. So it should be joule. How? It should be
Sir, কাজের
picojoule.
একক
How?
হবে। What second joule, sir?
What second means?
Joule, sir.
It's
Joule,
what
sir.
second? What means what? What is basically joule per second? That means work done per unit time. That is what? Or joule per second multiplied with second. So second and second allowed, and ultimate result is joule. Got it? What is basically work done per unit time? So work done is joule per unit time, that is per second. So final result is picojoule. Is it okay?
Yes, sir.
Yes, sir.
And the last one, last performance parameter, that is what? Last performance parameter.
So noise margin.
Sir, noise margin.
Okay. The fan out or capital N deals with voltage or current. What we have seen. The fan out or capital N deals with
Sir, current.
current. Fan out or capital N deals with current I. Noise margin deals with voltage. So please note it down. Noise margin deals with voltage. And Vn, we use Vn to represent noise margin. And we use capital N to represent fan out. Okay. Vn to represent noise margin. V for voltage and N for noise. That deals with voltage V, and unit is, what should be the unit? Unit should be volt. Okay, so let's see the diagram. Let's say this is output and this is input. Okay, one is output, another one is input, and this is output high state, logic high, and this is output low state. Similarly, input high and input low. Got it?
Yes, sir.
Okay. Now at this point, this one, can you write it's VOH max? B for voltage, O for output, because this one is for output state, and this is high logic, that's why H, and maximum value. Can you write?
Yes, sir.
So this one, what is it? V
OH.
OH. This one is minimum. The upper one is the maximum value, and this is minimum value. Got it? So both are for high state output. Have you noticed the difference? Have you noticed the difference?
Yes, sir.
Rest of all sleeping?
Yes, sir. No, sir.
Sir.
Okay,
No,
this
sir.
one. This one.
Sir, VOH minimum, maximum.
Max হবে, sir.
V O.
ওই
Is it H or L?
L, sir. L maximum.
UL max.
This is low, logic low, that's why VOL, and its maximum value. And the bottom one,
VOL minimum.
minimum. Similarly for input side,
VIH maximum, VIH minimum.
VIH max, and this one VIH minimum. Similarly this one,
VIL.
both are VIL. This one is
Maximum and
minimum and maximum. Got it? So how to write the equation for noise margin? One is VNH, that means high state noise margin. Another one is VNL. One is high state noise margin, another one is low state noise margin. So noise margin is basically the circuit's ability to tolerate noise at the input side, that is known as noise immunity, and the quantitative measure, that means in terms of numeric value, that is known as noise margin. Okay, the quantitative measure of noise immunity is known as noise margin. Got it? So how can you write the equation for VNAs and VNL? So for VNAs, the difference between these two levels, this is VNAs because both are high state. Similarly, the difference between these two, that is known as VNL. Okay, VNAs and VNL. So can you guess the equation for VNAs?
স্যার আমরা দুইটারই ম্যাক্সিমামটার সাথে কম্পেয়ার করছি ডিফারেন্স।
No. This one is both minimum and this one is both maximum. Okay. Is it maximum or minimum? This point?
Sir,
মিনিমাম
point.
মিনিমাম
Minimum. This one?
Minimum.
মিনিমাম।
That means difference between these two minimum. From where you will get the A's. Okay, because both are 1 1. And here both are maximum. This one maximum, this one also maximum for low level. That's why L. So just write the equation from this diagram. Just difference between these two level. Difference mean what should be the sign? Difference means the sign should be negative, okay, or minus. So the first one is VOAs minimum minus VIAs minimum. Got it? VOAs minimum, the upper one, minus the lower one, VIAs minimum. This is high state noise margin. Now write down the equation for low state. Very simple. Just upper one minus lower one.
VIL max.
VIL max or OL max first?
স্যার ওএল ভিওএল ম্যাক্স।
Upper one minus lower one.
স্যার ভিআইএল স্যার
VIL. VIL max
মাইনাস
minus
ভিওএল ম্যাক্স।
VOL max. Okay, this is high state noise margin and low state noise margin. If you have any confusion, then you can ask. Any confusion? Any confusion?
No sir, no confusion.
So can I raise the window?
Yes, sir.
Yes, sir.
Yes.
Okay, our next topic is CMOS design. CMOS stands for complementary, then
Metal oxide silicon.
metal oxide semiconductor, that is CMOS, complementary metal oxide semiconductor. So let's see the basic structure of CMOS. It's very simple, just try to understand. CMOS, complementary metal oxide semiconductor. So why it is called complementary? Because to design a CMOS, we have to use both PMOS and NMOS. Okay, we have to use both PMOS and NMOS to design CMOS. So always remember, this is the basic structure of CMOS, and the upper one is PMOS and the lower one is NMOS. So this is fixed. Always PMOS is connected with VDD and NMOS is connected to ground. Got it?
Yes, sir.
Yes, sir.
Okay. This is the input terminal for CMOS structure. This is output terminal. Okay, input and output terminal. Now if I draw the symbol for P and NMOS, now can you guess which one is PMOS and which one is NMOS? If you don't know, just let me know, sir. No, but don't waste your time. Are you familiar with the symbol? No, sir. Okay. So these are the symbol for PMOS. Okay, this one is PMOS, this one also PMOS. Okay, this one is PMOS and this one also for PMOS. That means the upper one. Both are PMOS. And this is NMOS. This one is NMOS. This one also NMOS. Got it? Both are NMOS. The lower one. The upper one, that is PMOS, and lower one, that is NMOS. So this is one set for P and N. This is another set for P and N. Noted? This is with bubble and without bubble. With bubble and without bubble. And this is with direction. Okay. This is with direction. And here is with bubble or without bubble. So let's identify the terminal. Gate. This one is drain. This one is source, or you can write vice versa. This is source and this is drain, because this is just symbol. This is gate, drain and source. So have you noticed the difference between these two symbols?
Yes, sir.
So there is a bubble at the gate terminal for PMOS, but there is no bubble at the gate terminal of NMOS. Okay, with bubble and without bubble. So I prefer to use this set of symbol, PMOS and NMOS with bubble and without bubble. So another symbol is, this is gate, source and drain for PMOS, and for NMOS this is gate, drain and source. Got it? The direction of current is from source to gate, that is PMOS. Direction of current that is from gate to source opposite, that is NMOS. Any confusion?
No, sir.
Any confusion? So we'll use this set of symbol, okay, for P and NMOS. Now this is CZ. CZ for common gate, C for common and Z for gate. This is CD. So can you guess CD? This one is common gate. So CD.
Common drain.
Common drain.
Common drain. So this one is source, because gate is here, drain is here. So the remaining one is source. So source of PMOS should be connected to VDD and source of NMOS should be connected to ground. Is it clear? Source of PMOS and source of NMOS. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now let's try to draw an inverter using CMOS logic. So what you know, to design a CMOS, you have to use both PMOS and NMOS. That means the number of input into 2. Number of input into 2. This 2 means 1 P MOSFET, 1 N MOSFET. For example, inverter. So how many inputs are there? For an inverter, how many inputs are there?
1.
So one.
Only one. So how many MOSFETs are required? How
Two.
many MOSFETs are required? Two MOSFETs are required. So single input means at least two inputs are required. So for example, 3 input. So how many MOSFETs are required?
3.
Input into 2. That means 3 into 2. So how many MOSFETs are required?
6.
Total 6. That means 3 P MOSFET and 3 N MOSFET. Got it? একটা ইনপুটের জন্য একটা পি একটা এনমস, সো এখানে তিনটা ইনপুট, সো টোটাল 6টা মসফেট লাগবে, তিনটা পিমস তিনটা এনমস। ইজ ইট ক্লিয়ার?
Yes, sir.
Yes, sir.
Now for inverter, if we follow the structure, the upper one is P or N as per the formation. The upper one is P or N?
Sir, upper one is P.
P. So let's draw a P MOSFET here with bubble at the gate terminal. Is it okay? The P MOSFET.
Yes, sir.
Then one is N MOSFET. One is N MOSFET.
Yes, sir.
Okay. So source of P MOSFET should be connected to which terminal? VDD.
VDD.
And the source of N MOSFET should be connected to ground.
Ground.
And as you know, for an inverter only one input is there. So common gate terminal, that is the input, and this one is common drain terminal, the output. Is it okay?
Yes, sir.
Is it okay? So let's identify the terminal. This is gate, this one also gate. So this is common gate terminal for input A. This is drain for PMOS, this one drain for NMOS. So common drain terminal for output. And the remaining source of PMOS, source of NMOS. This is NMOS and this is PMOS. Clear?
Yes, sir. Here.
Is it tough?
No, sir.
No, sir.
Just follow the structure. Now, just remember, anything designed using CMOS technology will get the inverted output. Okay. Anything designed with CMOS technology will get the inverted output. That means if you are asked to draw CMOS AND, what you have to do? At first you have to draw CMOS NAND, because anything designed with CMOS you will get the inverted output. So at first you have to design CMOS NAND, then you have to pass it through an inverter, that is also CMOS inverter, and finally you will get the output, that is AND. Clear? CMOS AND ডিজাইন করতে বললে আমাকে ফার্স্ট একটা NAND ডিজাইন করে দেন এটাকে ইনভার্টার দিয়ে পাস করানোর পর আমি ডিজায়ার্ড আউটপুট AND পেতে পারি। সিমিলারলি ফর OR, what should be the flow?
So not
First
Nor.
NOR থেকে, then inverter থেকে or.
Then inverter,
or.
finally we'll get OR. Okay. Now let's see how to design CMOS NAND, CMOS NOR. Now can you design CMOS inverter, everybody? Can you design CMOS inverter?
স্যার মনে হয় পারবো স্যার।
This is CMOS inverter that I have already designed. This is CMOS inverter. Input is A and output A bar. Okay. Now let's try to draw CMOS NAND. So before that, if you know this table, then the implementation will be very simpler. Whatever the function or whatever the equation. Okay, the upper position or the upper portion is PMOS and lower portion is NMOS, that you know already. So if the sign is dot, okay, suppose one example or one logical expression is given where the sign is dot, then PMOS should be parallel and NMOS should be series. Got it? If the sign is dot, the PMOS should be parallel and NMOS should be series. Noted, everybody?
Series. Yes, sir.
Okay. And if the sign is plus, if the sign is plus, the PMOS should be series and NMOS parallel. Okay, just opposite. So to design CMOS NAND, CMOS NOR, okay, you have to follow this table along with the formation. So suppose CMOS NAND, what is the equation? Let's say 2 input AB. So is it AB whole bar? Got it? CMOS NAND. Is it clear?
Yes, sir.
CMOS NAND A dot B whole bar. So in between the sign is what?
The dot.
Dot. That means we have to follow this one. PMOS
Yes.
should be parallel and NMOS should be series. Parallel
Yes.
means how many common point? Parallel means how many common point? 2 common point. And series?
The one.
Series means 1 common point. Okay. So what you know, for CMOS design, the upper portion for which one? P or NMOS? Upper portion for P or NMOS?
P,
PMOS.
sir.
This
PMOS.
is P and this is N. P is connected to VDD or ground?
VDD.
VDD, and N is connected to ground.
Ground.
So here A dot B, that means sign is dot. So PMOS should be parallel. So 2 inputs A and B. So how many MOSFETs are required? How many P MOSFETs are required? To implement this one, how many P MOSFETs are required? What I said, the number of input multiplied
Number of
with 2.
input,
That
two.
is total MOSFET. Okay, that is total MOSFET. So here number of input 2 multiplied with 2, that means total 4 MOSFETs are required.
4. Yes,
2
sir.
P MOSFET and 2 N MOSFET. Got it?
Yes, sir.
এখানে দুইটা P MOSFET এবং দুইটা N MOSFET লাগবে because 2 inputs. So for P MOSFET, the combination should be in parallel. So this is one P MOSFET, another P MOSFET, and parallel configuration, that means 2 common point. Is it okay? Input A,
Yes, sir.
input B, and P MOSFET is connected to VDD. Is it clear?
Yes, sir.
2 MOSFETs, they are in parallel. Now for N MOSFET, configuration
Series.
should be in series. So this is one N MOSFET, another N MOSFET which is connected to ground. So input A, input B, and this is the common output terminal. Any confusion?
No, sir.
The upper portion is PMOS. So 2 P MOSFETs are required for A and B. This one is NMOS. PMOS, NMOS. Okay, PMOS and NMOS. Can you identify the terminal?
Yes,
Gate,
sir.
drain, source. Can you identify?
Yes, sir.
Okay. So this is gate. This one also gate. So gate is dedicated to input. This one gate. This one also gate. What is it? Drain or source?
Source.
Source. This one also source. This is drain and drain. Now this one, what you know? This is common drain terminal. So obviously this one is drain
Drain.
and this one is source. Again, what you know, the source of NMOS should be
Source.
connected to ground. So this is source and this one is drain. Clear?
Yes, sir.
PMOS এর সোর্স থাকবে উপরের দিকে, NMOS এর সোর্স থাকবে নিচের দিকে। Clear? So at this point the output is A dot B whole bar NAND gate. Now if you are asked to design A dot B only, তখন কি করব? A dot B ডিজাইন করতে বললে, that means AND gate ডিজাইন করতে বললে
একটা ইনভার্টার লাগবে স্যার এটার সাথে।
আউটপুটটাকে একটা ইনভার্টার দিয়ে পাস করতে হবে, রাইট?
Yes, sir.
This is VDD, common drain, that is A, B. Okay.
Okay, sir.
Now can you draw CMOS NOR? CMOS NOR, just you have to follow this one. NOR means A plus B whole bar.
Yes,
It's
sir.
A plus B whole bar. That means PMOS should be in series. This is
And
one
NMOS
CMOS,
and parallel.
another PMOS. So they are in series and this is VDD. Okay. And NMOS should be in parallel. This is ground and this is the output terminal. Can you draw? Input A, input B for P MOSFET, and for N MOSFET, input A, input B. Can you draw?
Yes, sir.
Yes, sir.
This is common drain terminal, this is source terminal, and this is source of PMOS connected with VDD. So please practice it at your home for 3 input NOR, A, B, and C. It will be your homework. 3 input NOR along with OR. Okay.
Yes, sir.
Three input NOR first, then you have to pass it through an inverter, then you will get 3 input OR, A plus B plus C. It will be your homework. Can you solve?
Yes, sir. It's possible.
Okay. So any question? Any question from anybody?
স্যার হোয়াইট বোর্ডটা আবার একটু দেখা লাগবে স্যার, ওই যে ড্রয়িংটার
Board দেখা লাগবে। Can you see?
জি স্যার একটু ডান স্যার।
So can you see my screen?
Yes, sir.
Yes, sir.
Yes, sir. Okay. So have you checked it?
Yes, yes, sir.
Yes, sir.
Yes, sir. So don't wait for the last minute. Okay. So don't try to show any excuse, sir. আমি 11:50 তেই আপলোড করতে গিয়েছিলাম, বাট আপলোড হতে হতে টাইম শেষ। সো এই ধরনের কোনো এক্সকিউজ দেখানোর কোনো সুযোগ নেই, ওকে? বিকজ এটা অনলাইন সাবমিশন, এটা টাইমলি ডিসেবল হয়ে যাবে, এটা আমাকে ম্যানুয়ালি ডিসেবল করতে হবে না। সো মোস্ট অফ ইউ আর ফ্রম সিএসসি, রাইট? সো ইউ নো দ্য ফ্যাক্ট। Got it? So
Yes,
your
sir.
target should be to upload by 11:30. Okay, because load shedding can be there or some internet issues must be there, so you have to consider all the scenario. So your target should be to upload by 11:30 since the last time is 11:50. Got it? And here is the portal. You have to write your name. Okay, you have to write your name as in UIB ID, then student ID, then your section. What is your section?
F.
So here you will just write capital F, not like section. Okay, just write capital F and select your department and upload the PDF file, and you have to scan it by CAM scanner. Got it?
Yes, sir.
Handwritten and scanned by CAM scanner. And note down the instructions. You have to write your name and ID in each page top right corner. Okay, প্রত্যেকটা পেজে টপ রাইট সাইডে নেম এন্ড আইডি থাকবে। এন্ড পেজগুলো যখন আমি স্ক্যান করব মেক শিওর যেটা সিকোয়েন্স মেইনটেইন করেছি, দ্যাট মিন্স পেজ 1 2 3 4 এটা সিরিয়ালি যেন থাকে। ফার্স্ট ওয়ান
Yes, sir.
W X Y Z and O. So W X Y Z and O এই লেটারগুলো কি এগুলো থাকবে?
No, sir.
No, এটা কি হবে? First, second, third, fourth and fifth letter of your names as in AIB ID. So as per AIB ID তোমার লাস্ট নেমটা থাকে ফার্স্ট, রাইট? সো লাস্ট নেম যেটাই থাকুক না কেন তার প্রথম 5টা লেটার আমি নিব। যদি এমন হয় যে কারোর লাস্ট নেম হচ্ছে 3টা লেটার, সো 3টা লেটার নেওয়ার পর নেক্সট 2টা যে লেটার আসবে সেটা নিব। ফর রিপিটেড কেস সেটা অ্যাভয়েড করে নেক্সট যে লেটার আসবে সেটা নিব। ওকে,
স্যার এটা একটু আরেকবার বলবেন স্যার।
W X Y Z O এই লেটারগুলোর আমাকে রিপ্লেস করতে হবে কি আমার নিজের নামের ফার্স্ট, সেকেন্ড, থার্ড, ফোর্থ, ফিফথ দিয়ে। সো সাপোজ কারোর নেম হচ্ছে হক সামিউল, সাপোজ হক সামিউল অ্যাজ পার AIB ID, তাহলে এখানে H ফর কি W, U for X, Q for Y, this is Z and this is O or Q যেটাই থাকুক। তো W X Y Z এগুলোকে রিপ্লেস করব এই লেটারগুলো দিয়ে নিজের নামের। ওকে, ইজ ইট ক্লিয়ার?
Yes, sir.
যদি কারো নেম
জি,
থাকে
স্যার।
সাপোজ হাসান মেহেদি, এখানে কি করব? W কি হবে H, A হবে কি X, S হবে Y, Z কি হবে? Z কি হবে?
Sir, N হবে।
এটাকে এখানে এখন স্কিপ করো বিকজ রিপিটেড লেটার। সো এটা না নিয়ে জেডটা হবে আমার N আর নেক্সট লেটার আসবে এখান থেকে M। ক্লিয়ার?
Yes, sir.
তো ডাইরেক্ট কপি পেস্টের কোনো সুযোগ আছে এখানে? দোস্ত আমার টাইম নেই, তোর অ্যাসাইনমেন্টটা দে, আমি জাস্ট নাম এডিট করে দিয়ে দিব। সুযোগ আছে এখানে?
আছে স্যার।
কিভাবে স্যার? সেম নেম যদি থাকে?
না স্যার, আমাদের লাস্টে ইসলাম স্যার, তো ইসলামটা তো সবারই স্যার ফার্স্টে আছে, যে আমার নাম যেমন এমডি মনিরুল ইসলাম স্যার, ইসলামটাকে ইসলাম এমডি মনিরুল, তো যাদের নামে লাস্ট
আচ্ছা।
ইসলাম স্যার তাদের সবার মিলে যাবে।
ইসলাম, হাসান এগুলো কমন। সো ইউ আর লাকি গাইজ, রাইট?
ইয়েস স্যার।
ওকে, তো দেখো যদি এরকম কাউকে খুঁজে পাও দুজনে শেয়ার করো যে 3টা আছে, তুই 1.5 কর, আমি 1.5 করি। ওকে, কোশ্চেন রিভিউ করার কিছু নেই। একটা সিনারিও বলা আছে RFID বেসড একটা সিস্টেম, ডোর লক সিস্টেম, সেখানে আইডেন্টিফাই করতে হবে the logic based on the problem statement, then develop the truth table, then find the standard SOP and standard POS, then find the simplified SOP using KMap and design the system using basic gate. বেসিক গেট আমরা জানি and or and NAND। দেন এখানে একটা হাফ সাবট্রাক্টর এন্ড ফুল সাবট্রাক্টর ড্র করতে হবে, ব্লক ডায়াগ্রাম, একটা ট্রুথ টেবিল ডেভেলপ করতে হবে ফর বোথ, write the logic POS expression and design both half and full subtractor using basic gate। নাম্বার 3 যেটা বলা হয়েছে একটা উইথ ডোন্ট কেয়ার, একটা উইদাউট ডোন্ট কেয়ার। সো ফার্স্ট উইদাউট ডোন্ট কেয়ার আমি কনসিডার করব, তখন কে ম্যাপ করে আমাকে সিম্পলিফাইড পিওএস সিম্পলিফাইড এসওপি আনতে হবে। নেক্সট পোরশনে আমাকে ইউজিং ডোন্ট কেয়ার, সেম ইকুয়েশন জাস্ট ডোন্ট কেয়ার ইউজ করে আবার সেম ভাবে এসওপি পিওএস আনতে হবে। তারপর সেগুলোকে ইউনিভার্সাল গেট দিয়ে ডিজাইন করতে হবে, একবার নট দিয়ে, একবার ন্যান্ড দিয়ে, আর একবার কম্বাইন্ড ন্যান্ড নট যেটা সুইটেবল হয়। ওকে, clear?
Yes, sir. Clear.
So 3 questions and submission deadline 28 June। Submission কোথায়? So inbox বা মেইলে যদি কেউ সেন্ড করে থাকে এটা অ্যাকসেপ্ট করা হবে না। ওকে, টাইমলি যদি কেউ সাবমিট না করতে পারো এটা আর অ্যাকসেপ্ট করা হবে না। 3টা কোশ্চেন যে কোনো একদিন বসলে সলভ করা পসিবল। ওকে, যদি মনে হয় অনেক বিজি স্কেডিউল, প্রতিদিন একটা করে সলভ করো, নো প্রবলেম।
কি সিলেবাসটা বলে দিয়েছেন?
সরি, I cannot hear you. Taskia, কুইজের সিলেবাস? ওকে, কুইজ 3 এর সিলেবাস কি আমাদের? কুইজ 3 এর সিলেবাস সেকেন্ড কুইজের পর থেকে, দ্যাট মিন্স এনকোডার, ডিকোডার, মার্কস, ডিমার্কস এন্ড আজকের যে লেকচার।
Yes,
নেক্সট সানডে মিড টার্ম অ্যাসেসমেন্ট উইক। সো নেক্সট সানডে আমাদের কোনো ক্লাস হচ্ছে না, রেগুলার ক্লাস। আমরা নেক্সট টিউসডেতে মিড টার্ম প্লাস থার্ড কুইজের জন্য প্রিপেয়ার থাকবো along with ভাইবা। ওকে,
Okay, sir. Sir, তাহলে ক্লাস হবে না।
সানডেতে কোনো রেগুলার ক্লাস নেই আমাদের।
Okay, sir.
Okay, thank you all.